Halley's Comet is not the visitor you remember. You know its name, you might have seen the pictures, but the real story of this cosmic traveler is buried under layers of forgotten history and startling science. By the end of this journey, you will know 20 profound secrets that change everything about this famous streak of light. We will uncover a global panic over poison gas, explore why it once vanished from the sky, and question if it is slowly dying before our eyes. What do you truly believe is waiting for us in the darkness? The very first secret shatters our most basic assumption. Halley's Comet is not a permanent celestial monument, but a ghost of its former self. Every time it swings past the sun, it leaves a part of itself behind. You can think of it as a cosmic iceberg, a massive clump of ice and rock and dust drifting through the void. Scientists call this structure a dirty snowball, and that journey near our star is brutally transformative. Intense solar heat vaporizes the surface ice, blasting away plumes of gas and dust that form the glorious tail we admire from Earth. But that spectacle comes at a steep cost. Each orbit, Halley loses millions of tons of material. The comet you might have seen in 1986, or that your grandparents described, was already a weathered version. The one observed by the ancient Greeks, the one that struck fear into the hearts of medieval kings, was larger, brighter, and more massive. It carried more of its primordial ice, more of the dusty rubble from the solar system's birth. Today, it is a diminished traveler, slowly evaporating with every return. This constant shedding does more than just shrink it, it can subtly alter its very path through space. The jets of material acting like tiny, uneven rocket thrusters, nudging its trajectory in unpredictable ways over centuries. So the next time you hear its name, remember you are not hearing about a fixed point in the sky. You are following the story of a changing world, a dynamic and fading wonder that will not look the same for the next generation of skywatchers. This realization leads us directly to a second, even more startling secret about its very existence. This gradual fading of Halley's Comet is a quiet, cosmic process, but history shows us its arrival can trigger absolute pandemonium. The second secret is a story not of science but of sheer global panic. In the spring of 1910, the world braced for an encounter with the comet, but astronomers made a fateful announcement. They calculated that Earth would pass directly through the comet's immense tail. Today, that sounds like a harmless light show, but the newspapers of the era seized on a terrifying detail. Scientists had detected traces of a deadly gas called cyanogen within the comet's composition. The headlines did the rest, screaming that the planet's atmosphere would be poisoned, that the very air would become unbreathable. Imagine the terror. In an age before global communication could provide calm context, rumor and fear spread like wildfire. People in cities and towns across America and Europe rushed to buy quack remedies, so-called comet pills that charlatans promised would neutralize the toxins. Others sealed their windows and doors with wet towels and tape, attempting to create an airtight refuge in their homes. There were reports of individuals consumed by this collective dread, taking their own lives rather than face what they believed was certain, suffocating doom. The reality, of course, was a spectacular lesson in scale. A comet's tail is not a solid, poisonous fog. It is an almost perfect vacuum, far more diffused than the best vacuum we can create in a laboratory on Earth. The amount of cyanogen gas spread across millions of miles of space was so infinitesimally small that passing through it had no more effect than a single ship sailing through an ocean. The night came and went, and the world woke up to perfectly breathable air. This episode stands as a stark monument to what happens when a sliver of complex science meets the furnace of public imagination. It was not the comet that was dangerous, but the fear of the unknown it represented. This collision of discovery and misunderstanding reshaped how we see these visitors, turning them from omens into objects of study. Yet, even as we learn to stop fearing its tail, we would soon discover that Halley itself had once performed a far more alarming trick, a complete and total disappearance from the heavens. That collective panic in 1910 reveals how little we understood this cosmic clock, but long before we feared its chemistry, ancient civilizations recognized its timing, turning its appearances into a secret calendar etched across the sky. This brings us to our third secret. Halley's Comet is not just a spectacle, it is one of history's most reliable timekeepers. Its ancient appearances have literally rewritten our understanding of the human timeline. While medieval Europe often saw comets as divine omens of doom, other cultures were meticulous astronomers. Chinese court scribes for over 2 millennia kept detailed records of unusual celestial events, calling them guest stars or broom stars. Babylonian astronomers pressed observations into clay tablets with the same precision they used for tracking planets. These are not just curiosities. They are vital historical tools. Because Halley's orbit is so predictable, modern astronomers can run its clock backward, calculating exactly when it would have been visible from Earth in the distant past. When those calculations match a historical record, it gives historians an absolute fixed point in time. Think of it like finding a dated receipt in an archaeological dig. Everything else at that site, every artifact, every layer of construction can now be anchored to that specific year. One of the most famous examples is the Bayeux Tapestry, which depicts the Norman conquest of England. The tapestry shows King Harold and his court pointing anxiously at a star with a fiery tail in the sky. For centuries, this was thought to be symbolic. But when astronomers calculated Halley's orbit, they found it was brilliantly visible in the spring of 1066, just months before the Battle of Hastings. The tapestry is not showing a metaphor, it is recording an actual astronomical event that the people of the time witnessed, a celestial portent that now helps date the entire narrative with incredible accuracy. We can go even further back. Chinese records describe a spectacular broom star in the year 164 before Common Era. Our orbital calculations confirm Halley was there. Another detailed account from 87 before Common Era, likely seen by the eyes of ancient Romans and Han Dynasty astronomers alike. Each of these sightings is a pin in the map of time, allowing scholars to synchronize chronicles from different empires, to verify the reigns of kings, and to build a unified timeline of human civilization. So this comet is far more than ice and dust. It is a silent witness that has passed overhead at the birth of empires and the fall of kings, its predictable return providing a steady pulse against which the chaotic story of humanity is measured. And if it is such a perfect clock, why did it once vanish from the sky for generations, leaving astronomers to believe it was gone forever? That perfect celestial clock, however, can sometimes deliver a disappointing show. Our fourth secret explains why one of its most anticipated returns became famous for being a cosmic letdown. For years leading up to 1986, the world buzzed with excitement. Halley's Comet was coming back. A generation that had only read about it in history books would finally see this legendary visitor with their own eyes. Newspapers promised a brilliant spectacle, a once-in-a-lifetime event. But for the vast majority of people who stepped outside to look, the experience was deeply underwhelming. Instead of a blazing, unmistakable sword across the heavens, most saw only a faint, fuzzy smudge of light if they could see anything at all. It was not a failure of the comet, but a lesson in orbital geometry. The timing of its dance around the sun was simply unlucky for Earthbound viewers. When Halley was at its brightest and most active, closest to the sun, it was positioned on the far side of that star from us. The sun itself was literally in the way, blocking our view of the comet at its peak. By the time it swung around to our side of the solar system, where we could get a clear look, it had already moved much farther away from the sun's heat and light, growing dimmer and less spectacular. To make matters worse, its path across our sky kept it low on the horizon for most of the northern hemisphere, where the majority of humanity lives. This meant observers were looking through the thickest, most turbulent part of Earth's atmosphere, which blurred and dimmed the view even more. And for city dwellers, the ever-present glow of light pollution washed out that faint smudge completely. Compare this to the brilliant displays of 1835 or 1910, when the comet passed much closer to Earth and was high in a dark, pre-industrial sky. Those appearances were truly awe-inspiring, searing themselves into cultural memory. The 1986 return, by contrast, was a subtle whisper. Yet this disappointment held a silver lining. It forced a shift in perspective. Because the view from the ground was so poor, the real story of that return happened in space. For the first time, a fleet of robotic spacecraft from Europe, Japan, and the Soviet Union raced to meet the comet, giving us our first close-up look at its dark, potato-shaped nucleus. The disappointment on Earth paved the way for revolutionary discovery in space, proving that Halley's true secrets were not in its tail but in its heart. And that heart, as we would soon see, was nothing like the smooth, icy ball everyone had pictured for centuries. Those spacecraft revealed a dark, cratered world, but they also raised a deeper mystery about where Halley truly came from. This leads to a fifth secret, a cosmic question of identity. Halley's Comet might not be traveling alone. For over a century, astronomers have tracked another periodic visitor, a comet named Pons-Brooks. It follows an orbit that is strikingly similar to Halley's, a long, stretched-out ellipse that takes it from just beyond Earth out to the distant realm of the giant planets. The resemblance is too close to be mere coincidence. This has led to a compelling hypothesis. What if these two comets are siblings, fragments from a single, much larger parent body that shattered in the deep past? Imagine a colossal iceberg of primordial ice and rock, drifting silently for billions of years. Then, a gravitational nudge from a passing star, or perhaps the tidal forces of the sun, cracks it apart. The two largest pieces drift away from each other, each carrying a portion of the original's material and momentum. Over countless orbits, the subtle gravitational kicks from planets, especially the massive King Jupiter, would have slowly tweaked their paths, making them diverge just enough to appear as separate objects in our modern records. This idea of comet families is a key part of understanding the solar system's chaotic history. We see it clearly in the asteroid belt, with groups of rocks sharing nearly identical orbits, all pointing to a common origin in some ancient collision. For comets, the evidence is harder to pin down because their orbits are constantly being perturbed. Their histories were written by every planetary encounter. But the orbital kinship between Halley and Pons-Brooks is a tantalizing clue. If they are truly twins, then every appearance of Pons-Brooks offers us a glimpse of what Halley's lost sibling looks like, a chance to study the other half of a broken world. It suggests that the legendary comet we know so well is perhaps just one surviving piece of a grander, forgotten structure. And if comets can break apart, leaving siblings adrift, what other violent transformations has Halley endured that have literally shaped the world beneath our feet? The predictable clockwork of its orbit suggests a serene journey, but Halley's comet has a volatile temper. Our sixth secret reveals moments of unexplained fury, violent outbursts of light that defy all logic. Comets are supposed to be most active when roasted by the sun's heat, yet Halley has erupted in brilliance while languishing in the deep freeze of the outer solar system. The most stunning example occurred in 1991, a full 5 years after its last close pass by the Sun. The comet was a dark, frozen speck drifting beyond the orbit of Saturn, nearly 2 billion kilometers from the Sun's warmth. Then, without warning, it began to shine. Over just a few months, its brightness skyrocketed by a factor of 300. From the perspective of a distant telescope, it was as if someone had thrown a switch, turning a dormant rock into a miniature star. This was not a gentle brightening, it was a cataclysm happening in the silent dark, Astronomers scrambled for explanations, and the theories they proposed are as dramatic as the event itself. One possibility is a violent collision. Out in the Kuiper belt, the comet's home territory, space is not entirely empty. It is littered with icy debris, some no larger than a pebble, others as big as a mountain. Perhaps Halley slammed into one of these primordial leftovers. The impact would have been catastrophic, blasting a fresh crater into its ancient surface and throwing up a colossal cloud of pristine ice and dust that reflected sunlight with sudden, shocking intensity. Another, more subtle theory involves internal stress. The comet's interior is a chaotic mix of ices, some more volatile than others. As it recedes from the sun and cools, these gases can refreeze under pressure. A tiny shift, a thermal crack from the lingering chill of deep space, might have opened a sealed pocket. This would be like uncorking a shaken bottle of soda, causing a sudden, explosive release of trapped carbon monoxide or carbon dioxide gas, carrying reflective dust out into space in a brilliant plume. The most intriguing idea suggests a structural failure. Halley's nucleus is a fragile rubble pile, held together by little more than its own weak gravity. The immense temperature swings between its close solar passes and its distant exile could cause its crust to fracture on a massive scale. A whole section of its dark, dusty outer shell might have split open like an egg cracking, exposing acres of pristine, sun-reflecting ice to the void for the first time in millennia. This single event teaches us that comets are not dormant between visits. They are dynamic, ticking time bombs of ice and rock, capable of spectacular change in the absolute cold and dark. Their history is written not just in slow evaporation, but in sudden, violent chapters. And if a comet can erupt from a deep freeze, what other dormant forces might be waiting within its ancient structure, perhaps even holding a record of a violence that once reshaped our own planet? These sudden outbursts in the dark are a reminder that Halley is constantly shedding its own substance, leaving a ghostly fingerprint across the solar system. This brings us to the seventh secret. Halley's Comet is not a solitary traveler. It is the parent of two spectacular cosmic storms. Every single year, in early May and again in late October, our planet sails through clouds of dust that Halley left behind. These are not random specks. They are the finely ground remains of its nucleus, the very material vaporized and blown off during its fiery passages near the sun. This debris does not disappear. It spreads out along the comet's entire orbital path, forming a vast, tenuous river of particles in space. When Earth's orbit intersects this river, our atmosphere becomes a shooting gallery. Individual particles, often no larger than a grain of sand, slam into the air at staggering speeds of over 200,000 kilometers per hour. The friction from this violent entry superheats the air around them, creating the brilliant, fleeting streaks of light we call meteors or shooting stars. The May display is known as the Eta Aquariid meteor shower, seeming to radiate from the constellation Aquarius. The October show is the famous Orionids, appearing to flow from the Hunter Orion's club. For a few nights each year, Halley's ancient dust rains down upon us, a silent, fiery tribute to its journey. But this is far more than just a light show. It is a free scientific sample delivery. Think about it. Sending a spacecraft to chase down and capture a piece of a comet is one of the most difficult and expensive endeavors in space exploration. Yet twice a year, Halley's Comet sends fragments of itself directly to us. As these meteors vaporize, they leave behind a faint, glowing trail of ionized gas. By analyzing the light from this trail with sensitive spectrometers, scientists can determine the exact chemical composition of the vaporized dust. It is like taking the comet's fingerprint from 100 million kilometers away. Each fiery streak confirms the presence of water ice, carbon compounds, silicates, and metals that make up the comet's primordial building blocks. So when you look up during the Orionids, you are not just watching pretty lights. You are witnessing the final, blazing moments of Halley's own body, a cosmic autopsy that reveals the secrets of our solar system's infancy. And if we can learn so much from the dust it sheds, what profound truth might be locked away within the larger, stranger objects it has hurled toward our world? That annual rain of dust is a gentle reminder of the comet's slow dissolution, but history records a moment when its decay was anything but gentle. The eighth secret is a story of celestial violence so extreme it may have shattered the comet's very heart. In the year 837, according to meticulous Chinese astronomers, Halley's Comet did not just appear in the sky, it dominated it. Their records describe a visitor of terrifying brilliance, shining as bright as the planet Venus, with a tail that stretched an unimaginable 90 degrees across the heavens. To put that in perspective, hold your arm out straight and make a fist. That fist covers about 10 degrees of sky. The comet's tail spanned 9 times that distance, a blazing sword nearly from the horizon to the point directly overhead. This spectacular display had a simple, terrifying cause. Calculations show that in 837, Halley made one of the closest approaches to Earth in all of recorded history, passing within a mere 5 million kilometers. At that proximity, the sun's gravitational pull and blistering heat would have been ferocious. The comet was not just being warmed, it was being roasted alive. The sheer volume of ice vaporized in that single pass must have been staggering, a catastrophic loss of material that would dwarf the gentle shedding we see today. This presents a profound mystery. Where did all that lost material go? When a comet sheds that much mass so quickly, it is not a clean process. The nucleus, a fragile rubble pile, is under immense thermal and gravitational stress. It is entirely possible that the 837 event was not just a display but a disintegration. A large fragment, or even multiple fragments, could have broken away from the main nucleus in a violent fragmentation event. Think of it as a cosmic landslide where a whole section of the comet's mountain of ice sheared off and drifted into its own orbit. This lost fragment would have been a comet in its own right, perhaps several kilometers across, carrying with it a fortune of primordial solar system material. If such a breakup occurred, the debris field from that single encounter would have been immense. It would have scattered across the inner solar system like shrapnel from an explosion. Some of that debris would have slowly spread along Halley's orbital path, enriching the meteor streams we pass through today. Other, larger chunks may have been flung onto entirely new trajectories, becoming unseen, dark wanderers that cross Earth's orbit on paths we do not yet recognize. So when we witness the Orionid meteors each October, we might not just be seeing dust from Halley's recent passes. We could be watching the final, fiery remnants of that ancient cataclysm, the last echoes of a day when the comet came so close it nearly came apart. And if a piece of Halley did break free over 1,000 years ago, where is it now? And could its ghostly path still pose a secret threat to our world? The cataclysmic brilliance of 837 was a spectacle born of loss, a preview of the comet's ultimate fate. This brings us to a ninth sobering secret. Halley's Comet is running out of time. Every 76-year sprint past the sun is not just a journey, it is a slow execution. We have already seen how each pass strips away millions of tons of ice and dust. This is not a sustainable cycle, it is a countdown. Astronomers have begun to project its future, and the possibilities are stark. One path leads to a quiet fade. As the most volatile ices, the water and carbon dioxide and carbon monoxide, are steadily boiled away, the comet's activity will dwindle. What remains will be a dark, crusty mantle of refractory material, a thick layer of dust and tar like organic compounds that shields any remaining ice from the sun's heat. The glorious tails will cease to form, the brilliant outbursts will stop, Halley will no longer look like a comet at all. It will become a dormant, asteroid-like rock, silently tracing its familiar orbit but offering no spectacle, a ghost of its former self. The other possibility is more dramatic. The solar system is a gravitational pinball machine. With each pass through the inner planets, especially near the massive bulk of Jupiter, Halley's path receives a tiny, unpredictable nudge. Over hundreds of thousands of years, these cumulative nudges could add up to a radical change. Its orbit could become unstable. One particularly close encounter with a giant planet might fling it onto a new trajectory, hurling it out of the solar system entirely to become a dark wanderer in interstellar space, or perhaps sending it careening into the sun. Current estimates suggest our window to witness Halley as an active comet is startlingly short. Scientists calculate it may only survive for another 100,000 to 1 million years. In the 4.5 billion year life of our solar system, that is merely a blink. It means every recorded appearance in human history, from the Babylonians to the Bayeux Tapestry to 1986, has occurred in the final fleeting chapters of its long life. We are not just observers of a permanent celestial clock. We are a privileged audience attending the last act of a cosmic performance that began before Earth itself was formed. This realization forces a profound question. If we are watching its final millennia, what other ancient, fading wonders are passing us by right now, unseen in the dark? Its inevitable fade is a slow dance dictated by gravity, but the music of that dance is far from predictable. The 10th secret reveals Halleys Comet is not on a fixed rail through space, and its future path holds genuine surprises. Predicting where it will be 76 years from now is precise science, but forecasting its position 1,000 years into the future is an exercise in chaos. This uncertainty stems from two powerful and often competing forces. The first is the subtle push of its own breath. As the sun heats the comet's irregular surface, jets of vaporizing gas erupt from cracks and fissures. These are not symmetrical puffs. They act like tiny, misaligned rocket engines, giving the nucleus a slight nudge with every rotation. Over a single orbit, this non-gravitational force, as scientists call it, is minuscule. But compounded over centuries, it can shift the comet's arrival time by months and alter its distance from the sun by millions of kilometers. It is as if a finely tuned clock had a tiny, erratic heartbeat of its own, slowly throwing its hands out of sync. The second, more dramatic force is the gravitational pull of the planets. Halley's elongated orbit is a thread weaving through the entire inner solar system, and every close pass to a world like Venus or Earth, and especially the giant Jupiter, gives that thread a sharp tug. One of the most significant events in its foreseeable future will occur in the year 2134. During that return, Halley will make an exceptionally close approach to Venus. The planet's gravity will whip the comet around, significantly altering its speed and trajectory. This planetary encounter will act as a cosmic reset button, calculating a new countdown for its next appearance. Because of these constant perturbations, tracing Halley's orbit backward or forward in time becomes a turbulent calculation. Small errors in measuring its current position or in modeling the uneven thrust of its gas jets magnify exponentially over time. We can say with confidence it will return in 2061, but we cannot say with the same certainty exactly where it was in 10,000 before Common Era, or where it will be in the year 10,000. This injects a fundamental element of mystery into an object we think of as the ultimate celestial clock. Its orbit is not a pristine ellipse drawn on a chalkboard. It is a living, breathing path, constantly rewritten by the silent hiss of its own evaporation and the gravitational whispers of the planets. So the next time you mark its return on a calendar, remember you are not just noting an appointment. You are anticipating a meeting with a traveler whose journey is being subtly redirected, even now, by forces we can measure but never fully control. That living, breathing path has been watched by humanity for millennia, but rarely with the cool detachment of science. Our 11th secret plunges us into the darkest chapters of that observation, where Halley's Comet was not a clock but a curse. For centuries, its sudden, brilliant appearance in the night sky was interpreted as a direct omen of doom, a celestial warning of divine wrath. This fear was not a vague superstition. It was woven into the very fabric of historical record, with the comet's return blamed for some of the most pivotal disasters in human memory. In the year 814, a brilliant comet blazed in the heavens. That same year, the great Emperor Charlemagne, the father of Europe, lay on his deathbed. To the people of his empire, the connection was undeniable. The comet was a fiery herald sent to escort the soul of a king, a sign that the very order of the world was shifting. The chroniclers did not see coincidence, they saw cause. Centuries earlier, in the year 66, a comet with a sword-like tail was recorded. Just a few years later, the Great Fire of Rome erupted, consuming much of the city. While Emperor Nero famously fiddled, the public memory fused the events. The comet had been a portent of the flames, a signal of the gods' displeasure that would manifest in the city's destruction. Perhaps the most poignant connection was made in 1453, as the great city of Constantinople, the last bastion of the Roman Empire, endured a brutal siege by the Ottoman Turks. A comet streaked across the sky above its beleaguered walls. To the desperate defenders, it was the final, terrible sign. Their city, the center of Christendom for 1,000 years, was doomed. The comet's appearance confirmed their deepest fears, and within months the city fell, an event that reshaped the map of the world. Why did this one celestial object become such a powerful vessel for our dread? Its very nature made it the perfect symbol. Unlike the orderly march of planets or the fixed patterns of stars, a comet arrived without warning to the average person. It was unpredictable, chaotic, and terrifyingly beautiful. It violated the perceived perfection of the heavens with its wild, untamed tail. In a worldview where the sky reflected divine will, such a disruption could only mean one thing. The gods were angry, and they were sending a message. Kings and empires rose and fell by this logic. A comet's arrival was seen as a direct commentary on a ruler's legitimacy, a sign that their power was being questioned by a higher authority. This embedded Halley and comets like it deep within our cultural psyche. They became shorthand for impending catastrophe, a narrative so powerful it echoes in our art and literature to this day. But what if this ancient fear was not entirely misplaced? What if the comet, while not an omen, was actually capable of delivering a very real physical catastrophe from the skies it once haunted? That ancient fear of a celestial omen was rooted in what we could not see, but the true shock came when we finally saw the comet's face. The 12th secret was delivered not by a telescope, but by a brave little spacecraft on a suicide mission. In 1986, as Halleys Comet made its disappointing pass for Earthbound viewers, the European Space Agency's Giotto probe was racing toward it on a collision course. Its goal was to plunge into the comet's coma, that cloud of gas and dust, and capture the first ever close-up images of the nucleus itself, the hidden heart of the legend. Scientists were brimming with expectation. They had long described comets as dirty snowballs, implying a bright, icy surface peppered with a bit of dust. The images Giotto sent back just seconds before it was battered into silence by high-speed debris caused a collective gasp in control rooms. There was no bright, gleaming iceberg. Instead, they saw an object of profound darkness. Halley's nucleus was blacker than coal, one of the darkest objects ever measured in our entire solar system. This was not a dirty snowball, it was an icy dirtball. The probe's data revealed a cosmic charcoal briquette roughly 15 kilometers long, shaped like a lumpy potato. Its surface, reflecting less than 4% of the sunlight that hit it, was covered in a thick, crusty mantle of complex organic compounds. Think of it as a layer of primordial tar, a sun-baked crust of carbon-rich material that had formed over the eons as the more volatile ices beneath it slowly evaporated away. This dark crust acted like an insulating blanket, protecting the precious reservoirs of water ice and frozen gases sealed within. The revolutionary insight was that comets were not mostly ice with a little dirt. They were ancient rubble piles where rock and dust were bound together by ices, and then shrouded in a dark skin of complex chemistry, possibly the very building blocks of life. Giotto's sacrifice forever changed the textbook image of a comet. It showed us that the brilliant, ethereal visitor we see in our skies is born from one of the darkest, most primordial objects imaginable, a cosmic paradox where light springs from absolute blackness. That profound darkness revealed by Giotto forced us to rewrite the very definition of a comet, but long before we saw its face, Halleys Comet played a far grander role. It was the key that unlocked the universe. Our 13th secret is that this wandering light did not just pass through history, it helped create the scientific age we live in. For millennia, comets were seen as atmospheric phenomena, vapors burning in the upper air, or as divine messengers completely outside the laws that govern the planets. They were the ultimate symbol of cosmic chaos. Then, in the late 1600s, a brilliant friend and collaborator of Isaac Newton named Edmund Halley made a daring intellectual leap. He took Newton's revolutionary new laws of motion and universal gravitation and applied them to the messy, unpredictable paths of comets. Poring over historical records, he identified a pattern. The comets seen in 1531, 1607, and 1682 followed such similar orbits that he proposed they were not three different objects, but a single comet returning roughly every 76 years. Using Newton's equations, he calculated its path and made a stunning prediction. He declared this comet would return again in late 1758 or early 1759. This was a monumental gamble. Halley knew he would not live to see it. He died in 1742, but he staked his reputation and the validity of Newton's entire system on this future event. As the predicted year approached, the scientific world held its breath. Would the heavens obey a human calculation? Astronomers across Europe trained their telescopes on the appointed patch of sky. Finally, on Christmas night, 1758, a German farmer and amateur astronomer named Johann Palach spotted the faint, fuzzy visitor right on schedule. The confirmation was electrifying. For the first time in human history, a celestial object previously seen as a portent of chaos had been predicted with mathematical precision. This was more than just checking a box. It was a thunderous declaration that the cosmos operated by knowable, predictable laws. The comet was not a supernatural anomaly. It was a celestial body governed by the same gravity that pulls an apple from a tree. This single event shattered the ancient Aristotelian view of perfect, unchanging heavens. The sky was no longer a divine, immutable clockwork. It was a dynamic system of moving worlds, some of which, like Halleys Comet, only revealed themselves on long, elliptical journeys. Edmund Halley's successful prediction cemented the scientific method as a tool for unlocking the future, transforming astronomy from a practice of observation into one of prediction. It helped ignite the Enlightenment, an era built on the idea that reason and observation could demystify the world. So every time we mark its return on a calendar, we are not just noting an astronomical event. We are celebrating the moment humanity learned to read the clockwork of the cosmos. And if this comet helped birth modern science, what other, more personal revolution did it spark in the mind of a young artist who saw it blaze overhead? Edmund Halley's triumphant prediction should have settled the comet question, but the heavens had one more trick to play. Our 14th secret reveals a case of mistaken identity so convincing it fooled the greatest scientific minds of the age. Decades before Halley made his famous forecast, another comet blazed across the sky in 1680. It was a magnificent sight, visible even in broad daylight, with a tail that stretched an incredible 70 degrees. Both Halley and his colleague Isaac Newton observed it with awe, meticulously tracking its path. For years afterward, a compelling idea took hold. Given the rough 76-year period Halley would later establish, some wondered if this brilliant 1680 comet was simply an earlier return of the same object he would later make famous. It seemed a logical assumption, two spectacular comets seen by the same man, separated by roughly the expected time frame. Perhaps Halleys Comet had been visiting all along, just waiting for someone to connect the dots. This assumption, however, was a beautiful illusion. As the mathematics of celestial mechanics grew more sophisticated in the centuries that followed, astronomers recalculated the orbit of that 1680 visitor with far greater precision. The truth was startling. The 1680 comet was not on a closed, elliptical path like Halley's. Its orbit was hyperbolic, an open curve like a shallow arc. This meant it was not a member of our solar system's family of periodic comets, trapped in an endless dance around the sun. It was a visitor from interstellar space, a lone wanderer that happened to swing through our neighborhood on a one-way trip. The sun's gravity bent its path, but it possessed too much speed to be captured. It whipped around our star and was flung back out into the galactic void, never to return. This discovery was a humbling lesson. It showed that even the most brilliant observers, working with the best tools of their time, could be misled by cosmic coincidence. The confusion between the 1680 comet and Halley's true comet underscores the painstaking detective work required to map the heavens. Astronomers had to become celestial historians, sifting through ancient records, correcting for observational errors, and applying ever more refined mathematics to separate fact from assumption. That single hyperbolic comet taught them that the sky contains both permanent residents and fleeting tourists, and telling them apart requires more than just a notebook and a telescope. It requires the patience to wait for the universe to reveal its patterns, one orbit at a time. And if a comet can be a one-time tourist from the galaxy, what does that tell us about the very origin of the object we call Halley? Where, in the vast dark, did its long journey truly begin? That fleeting interstellar tourist from 1680 highlights a crucial distinction, but the comet we know as Halley is no casual visitor. It is a permanent resident with a profound origin story. Our 15th secret reveals Halleys Comet is not just a traveler, it is a frozen library, a pristine archive of our solar system's raw beginnings. Unlike the planets which have been melted, cratered, and transformed by billions of years of geological violence, Halley has spent most of its existence in deep freeze. It originated in the distant Oort cloud, a vast spherical shell of icy remnants surrounding our solar system far beyond the orbit of Pluto. Out there, in the perpetual dark and cold just a few degrees above absolute zero, time stands almost still. The comet's fundamental ingredients, the ices and the dust grains locked within its nucleus, have remained largely untouched for 4.6 billion years. They are the same materials that swirled in the protoplanetary disk before the sun even ignited, before Earth was a glimmer of coalescing rock. When we study Halley, we are not studying a world. We are conducting an archaeological dig on the solar system's infancy. The spacecraft that visited it in 1986 and the meteor showers its dust creates today act as our remote sensing tools. They allow scientists to perform a cosmic chemistry experiment. One of the most telling clues is found in the water. By measuring the ratio of different types of hydrogen atoms called isotopes within the comet's water ice, researchers can compare it to the water in our oceans. The results are startlingly similar. This suggests that a significant portion of Earth's water, the very essence of our life-giving oceans, may have been delivered by ancient cometary bombardments, with objects like Halley serving as the delivery vehicles. But the library holds more than just water. Spectral analysis has detected the presence of complex organic molecules, the carbon-based building blocks essential for life as we know it. These are not simple compounds, but more complex chains and rings of carbon, hydrogen, oxygen, and nitrogen. They are the kind of prebiotic chemistry that, when delivered to a warm, wet young planet like Earth, could have provided the starter kit for biochemistry. So within that dark, coal-like nucleus is a record of the very ingredients that eventually led to rocky planets, vast oceans, and perhaps even the first stirrings of biology. Halley's Comet is a messenger from a time before time, carrying in its frozen heart the original recipe from which our entire world was baked. That frozen library of primordial chemistry holds one more nearly invisible chapter. Halleys Comet possesses a third, ghostly tail that few have ever seen. Beyond the brilliant white dust tail and the ethereal blue ion tail lies a subtle, yellow-tinged stream made entirely of sodium atoms. This was a stunning and unexpected discovery during the comet's 1986 return. Astronomers using specialized filters designed to detect the faint glow of sodium gas saw something extraordinary. Stretching millions of kilometers behind the comet was a vast, tenuous structure, completely separate from the two main tails. It was as if the comet was exhaling a faint, golden breath into the void. The existence of this sodium tail presented an immediate and profound mystery. Sodium is a highly reactive metal commonly found in rocky minerals, not in the volatile ices that make up a comet's primary structure. How could a dirty snowball, a body dominated by frozen water and gases, be spewing atoms of a metal? The mechanism that strips sodium from the comet's rocky dust grains and ejects it with such force remains one of the great unanswered questions in cometary science. One theory suggests a two-step process. First, ultraviolet sunlight or energetic particles from the solar wind could knock sodium atoms loose from the surfaces of tiny dust grains within the comet's coma. Then, the gentle but persistent pressure of sunlight itself, a force called radiation pressure, might push those lightweight atoms away, forming the distinct straight tail. Another, more dramatic idea involves a kind of cosmic sandblasting. As the comet's dust grains collide with each other in the chaotic environment of the inner coma, the impacts could vaporize tiny amounts of rock, releasing a vapor that includes sodium. This faint yellow signature is more than a curious detail. It is a direct signal that the chemistry happening on and around the comet is far more complex than we ever assumed. The nucleus is not just passively evaporating. It is an active chemical factory where sunlight, solar wind, and colliding dust are transforming solid rock into an invisible, streaming gas. This ghostly third tail is a powerful reminder that even an object as famous and well-studied as Halley's Comet still guards fundamental secrets. It whispers that for all our telescopes and spacecraft, we have only just begun to read the full story written in its light. The ghostly sodium tail is a whisper of hidden chemistry, but another chemical signature from Halley shouts a contradiction. Data from those 1986 spacecraft revealed a startling chemical anomaly. Halley's Comet possesses far less carbon monoxide than almost any other comet we have studied. Carbon monoxide is one of the most common volatile ices in the cosmos, a fundamental building block frozen into cometary nuclei from the very beginning. Finding a comet low in carbon monoxide is like finding a saltwater ocean that is not salty. It defies expectation and demands an explanation. So where did Halley's carbon monoxide go? One compelling hypothesis points to an ancient solar oven. Billions of years ago, during the chaotic early days of our solar system, gravitational interactions with the giant planets could have flung Halley onto a different path, one that brought it much closer to the Sun for an extended period of time. If it spent millennia or even millions of years orbiting in the warmer inner solar system, the relatively weak bonds of carbon monoxide ice would have been the first to vaporize. The Sun's heat could have slowly baked it away, depleting this volatile gas long before the more stubborn water ice began to erode. This would mean the comet we see today is a survivor of a previous hotter chapter, its chemistry permanently altered by a forgotten journey. Another possibility is not about loss but about transformation. The carbon monoxide might still be there but locked away in a chemical prison. Within the extreme cold and under pressure, carbon monoxide molecules can become trapped in cages of water ice, forming what scientists call a clathrate hydrate. Think of it as a microscopic ice honeycomb with carbon monoxide gas sealed inside each tiny cell. This trapped gas would not be easily released by the sun's heat in the way pure surface ice would be. It would require the entire structural cage of water ice to break down first, a slower and more complex process. This would make Halley's carbon monoxide reservoir hidden, not missing, its release governed by a different set of rules. Each hypothesis paints a different portrait of the comet's deep past. The baking theory suggests a violent, dynamic youth with close solar encounters that scarred its chemistry. The trapping theory suggests a more complex internal architecture, a layered history written in icy chemistry. This single chemical deficit is a quiet clue screaming that Halley's story is not a simple one of frozen preservation. It has a thermal history, a record of warmth and change written into the very molecules that make it up. And if its chemistry was shaped by ancient heat, what other profound transformation might that same heat have triggered, one that forever linked this comet to the destiny of life on our own planet? That missing carbon monoxide speaks of a comet shaped by ancient forces, but in the modern era, Halley shaped something entirely different, the culture of an entire generation. The Panic of 1910 was not confined to sealed rooms and quack medicine. It exploded into a full-blown cultural phenomenon, birthing a surprising 18th secret. Halleys Comet inspired a smash hit song that captured the world's nervous excitement. As headlines screamed about poison gas, songwriters rushed to capture the public mood. The result was a jaunty, infectious piano tune titled Halleys Comet Rag. Its sheet music flew off the shelves, becoming a national sensation. The song's lively, syncopated rhythm belied its ominous subject, a perfect soundtrack for an era dancing on the edge of cosmic dread. People gathered around pianos in parlors across America to play it, turning a potential catastrophe into a shared, slightly giddy cultural moment. This was just the tip of a vast comet-themed commercial frenzy. Entrepreneurs saw not an omen but an opportunity. They sold everything imaginable. You could buy special Halleys Comet-branded telescopes, though many were cheaply made and offered little more than a blurry glimpse. For those fearing the tale, there were so-called anti-comet umbrellas and protective glasses, utterly useless but brilliantly marketed. There were comet-themed hats, pins, postcards, and commemorative plates. Restaurants offered comet cocktails, newspapers ran comet cartoon strips, and department stores held comet-themed window displays. This commercial storm reveals a profound human truth. When faced with the vast and unknown, we have a powerful instinct to domesticate it, to bring it down to a scale we can understand, purchase, and even hum along to. The comet was no longer just a distant scientific object or a terrifying biblical sign. It became a product, a trend, a piece of popular entertainment. This fusion of mass anxiety and mass marketing created a unique historical snapshot. The 1910 return was arguably the first global media event centered on an astronomical phenomenon. It showed how a streak of light in the sky could unite the world in a single, simultaneous experience, blending genuine scientific curiosity with rampant superstition and unchecked commercialism. In that moment, Halley's Comet was not just orbiting the sun, it was orbiting the human imagination, proving that our reaction to the cosmos can be just as complex and unpredictable as the cosmos itself. That cultural frenzy in 1910 was fueled by imagination and fear, but the next time Halley returns, the spectacle will be real, and the world will be watching in a way never before possible. The 19th secret is a promise written in orbital mathematics. The return of Halley's Comet in 2061 is poised to be one of the most spectacular celestial events in living memory. The reason is pure geometry. Unlike the disappointing 1986 apparition, where the comet was on the far side of the Sun from Earth, the 2061 alignment will be nearly perfect. Halley will swing around the Sun and then race back outward on a path that brings it relatively close to our planet. Current projections estimate it will pass within about 20 million kilometers of Earth, which is dramatically closer than its last visit. This proximity, combined with its position high in a dark summer sky for the Northern Hemisphere, will transform it from a faint smudge into a brilliant, unmissable landmark. Expect a core brighter than most stars, with a glowing coma the size of the full moon, and a shimmering dust tail that could stretch a third of the way across the heavens. It will be visible to the naked eye for weeks, a constant ethereal presence in the evening, and then the pre-dawn sky. But the historic nature of this return goes far beyond simple brightness. This will be the first apparition in the age of truly global, instant digital connectivity. Imagine a world where every smartphone is a potential telescope, where live streams from every continent paint a real-time portrait of the comet's evolution. Social media will erupt with shared images and wonder, creating a planetary conversation under the same celestial visitor. For science, the tools at our disposal will be revolutionary. Space-based observatories like the James Webb Telescope's successors will train their infrared eyes on Halley, probing the chemistry of its coma and tail with sensitivity we can barely conceive of today. We might even have dedicated interceptor missions, spacecraft designed to rendezvous with the comet and perhaps even land on its dark, ancient crust to sample its primordial ice directly. For anyone alive today who is young enough or yet to be born, this event represents a once-in-a-lifetime opportunity to connect with a rhythm far older than civilization itself. You will not need to read about the panic of 1910 or the calculations of Edmund Halley. You will step outside, look up, and see the same cosmic traveler that has witnessed all of human history, now brighter and clearer than it has been for centuries. It is a future appointment with destiny, a reminder that the universe keeps its own time, and in 2061, it is offering us a front-row seat to a show that will redefine wonder for a new generation. That brilliant spectacle awaiting us in 2061 offers more than just a view. It offers a vision of our future. The 20th and final secret transforms Halleys Comet from a celestial landmark into a potential cornerstone. We might one day not just visit it, but mine it. The very same ices that slowly boil away to form its glorious tail represent a treasure trove for spacefaring civilization. Picture a future mission decades from now that does not simply fly past Halley. It rendezvous with it, matches its speed, and lands a robotic factory on that dark, crusty surface. Its goal is not just science, but survival. It would drill through the insulating crust to reach the pristine water ice beneath, harvesting it by the ton. That water is liquid gold in space. Through a process called electrolysis, it can be split into its basic components, hydrogen and oxygen, the fundamental ingredients of the most powerful chemical rocket fuels we use. Halley, in this future, becomes a cosmic gas station. A spacecraft traveling from Earth to the outer planets could launch with minimal fuel, coast to an interception point with the comet, refill its tanks with propellant manufactured on site, and then continue its journey with a full load. This changes the entire economics of solar system exploration. Suddenly, the comet is not a destination but a depot, but the potential goes beyond mere fuel. Cometary ice is rich with other volatile compounds like carbon dioxide and methane, which could be used to create breathable air for habitats or raw materials for manufacturing in space. The dust and rocky material locked within the ice could be processed for metals and minerals. This concept, known as in situ resource utilization, turns Halley from a passive object of study into an active partner in our expansion. It would cease to be an omen of doom as the ancients saw it and become an engine of opportunity. This future is still speculative, fraught with immense technical challenges, from landing on a low-gravity rubble pile to operating machinery in the harsh environment of deep space. Yet the principle is sound. Halleys Comet and others like it are not just fossils. They are reservoirs. They carry the essential resources of life and propulsion scattered along highways in the sky. So when you look up at its next return, see more than a streak of light. See a stepping stone, a silent, orbiting stockpile that holds within its ancient ice the very keys to unlocking humanity's journey beyond our cradle, turning our oldest celestial fear into our greatest cosmic hope. So this is the comet you thought you knew, a journey transformed by 20 hidden truths. It is no longer just a streak of light, but a layered chronicle. It is a fading traveler, a once feared poison, a ghost that vanished and a clock that recalibrated history. It is a fragile sibling, a sudden eruption in the dark, and the parent of annual meteor storms. We have seen its cataclysmic close call, its impending end, and the chaotic forces that steer its unpredictable future. This object has been branded an omen of fallen empires and the very key that unlocked the scientific age. Its face is darker than coal, yet it holds the frozen library of our solar system's birth, complete with a ghostly third tail and a baffling chemical signature. It inspired panic, sparked a ragtime craze, and awaits a spectacular return. Ultimately, it stands as a promise, a future waypoint that could fuel our dreams beyond Earth. Halleys Comet is the ultimate duality, both a profound cultural touchstone across every human era and a scientific Rosetta Stone, translating the raw language of the cosmos into stories we can understand. So the next time you hear about the Orionid meteor shower, step outside, watch those streaks of light, and remember you are witnessing the final, fiery breath of this ancient wanderer. Mark your calendar for 2061 for a front-row seat to its next great performance. Tell us in the comments below which one of these 20 secrets changed your view of our cosmic neighbor the most. And if you crave more journeys into the unknown, be sure to subscribe for deeper dives into the universe's greatest mysteries.